So today, though, today we're going to talk a bit about context. Now that we've given you some context about ourselves, and specifically the context kind of required that makes AI data, agentic systems or agents reliable. So I think to kick it off, um, I think one of the really important things with like why context is so important is when we think about how we evaluate the sort of answers and output we get from AI data systems, however you're using it, right? Um, there's two, I think, main categories of how we evaluate whether they're good or bad or somewhere in between. And sometimes these words can get a bit conflated. But they mean very different things. So, capability and reliability are the two things we pay attention to a lot here at the lab. Reliability is, I think, one of the really important aspects that is actually like quite easy to measure. You can do it without having like a whole like golden data set or anything like that, or actually knowing the right answer. But it's not, I feel like, taken as seriously, but it's also one of these things where it's like it's really clear that a system's unusable if it's unreliable. So when I talk about capability and reliability, capability, this is kind of like, can this thing do the job at all? Can it read my warehouse? Can it write a query? Can it come back with a number? Or can it come back with the correct number at least once? And then reliability is around, and this isn't just for like data agents. This is any sort of like AI use case. I evaluate across these dimensions when I build systems for evaluation around like legal AI, for instance. Reliability is if I ask the same question tomorrow or today, am I going to get the same answer I did the first time? If I ask it 100 times, am I going to get the same answer every single time? If someone else asks that question on a completely different machine, are they going to get the same answer that I do? Um, and like a lot of the pattern we see, and we see it in our own courses and cohorts in the early weeks when we start building out agents as well, is like, you know, we will kind of have like a sort of like demo-ish moment where we see that this thing is capable. It can answer a question for us. Um, but then when we kind of like push that trial further and like multiple people ask the same question, they all get different numbers, or some people get the same numbers, some people get different numbers. And a lot of the times the conclusion at the end of that, the kind of knee-jerk reaction is like, oh, this thing doesn't work, right? Like, I don't know, the model is bad. And it's not necessarily that's bad. Every one of those people or those runs of those questions might have some very plausible, defensible reason behind why the agent eventually resulted in that output. It's capable, but it just isn't reliable. And unfortunately, an unreliable, I think, means unusable. And so we cannot have like production level like data agents or decisions made off of like data agents that are consistently unreliable. So we're going to kind of look a little bit at like what's actually happening there. I'm not going to open up Cloud Code today because we've given this kind of demo a few times in our past sessions where we discussed AI evals for agentic analytics. Yeah, I don't know, Hi, if you want to, or Stravia, if you want to dig into our past lightning lessons or maybe our YouTube channel and try and drop links to those. But we did do two past lessons on AI evals for and validation for agentic analytics, where we kind of go into how we measure reliability. So we won't go into that today, but at a high level, basically, we ask it our system like, hey, a kind of vague question like, what is our retention rate, for instance? That's a deliberately kind of broad question. that somebody, a stakeholder could ask, could drop in Slack, you could hear in a meeting where the term retention isn't actually like clearly defined, though many people in the room could think they know exactly what that definition is. And so when we ask that, and if you watch like this, that past lesson that High shared, when we ask it against our warehouse on Snowflake, it's like we asked it like 30 different times. We asked it across three different engines, meaning three different models, Opus, Fable, and open source model GLM 5.2. Um, we run it with a fresh session for every time we ask that. So nothing from one run to another pollutes. And what ends up happening is we usually get a bunch of different answers. So if we had just asked it one time, so like the first time we asked it to Fable, it comes up with this answer. It says like, yeah, retention is 25.3%. I noticed that even we even have like an audit trail that where it can tell us like how it was measured, like the share of customers whose first completed order was followed by a second completed order within 90 days. That sounds like a pretty good answer. Like the SQL, we check the SQL behind this is actually valid. It's ran against real warehouse. The math is correct for the query it wrote. It didn't really hallucinate any of that actual like analytics work. Um, and so it would be actually, if we just were validating it this way, it'd be really easy for us to kind of run this analysis and then share this number out with someone else. However, on that same Fable 5 model, we did 5 runs against that same engine on that same question. And actually, we got a spread of numbers across it. So um, it varied between 9.2 and 25.3. So it didn't answer 25.3 every single time. Same question, same data it's pairing from, but no definition for what retention was is in front of the model, which is obviously the context it needs, right? So nothing broke here. Um, if we open up any of these runs, we'd find like valid like SQL and execution of that SQL behind it. Like every one of them is correct in the respect to like the query it wrote, but they just wrote different queries because they were on their own answering different questions. And so you can imagine, like when we spread this out across like many runs, like 30 different runs, we start running into a bunch of different definitions that um, our agents are proposing when they don't have a definition available to them for what retention means. So in this case, we have an audit trail to identify like we showed up here, what each of those definitions are. And across like all these 30 runs, one decided retention meant the share of customers who came back the next month. One decided it meant people who bought twice within 90 days. One found a membership table and used the share of memberships that were still active. So that's like very different than the other two. Um, then this all happened because we hadn't written down what retention actually means. So each run had to go try and settle it on its own. The question we typed was somewhat ambiguous. And so every session is going to attempt to resolve that ambiguity differently. Unfortunately, it doesn't always tell us the choice that it made. And it gets so you can see like when we zoom out to like even more of these other engines. So if we split by engine here, they each go their own way. Opus is like pretty consistent. In this one run we did of it, but it was consistently on the same wrong fork. So 34.9 is not the answer we're getting from the other models. A Fable flipped kind of between these two answers, almost 50-50. And then our open model actually gave us a different number almost every time we pulled it, it gave us a different number. Yeah, 99.2 would be awesome, Rob. But like you can imagine this, right? Like you see like in the open model, like one run said because of one way defined retention gave us 99.2%, and another run it gave us 9.7%. They're just total. They're actually both like pretty decent definitions if you look behind what they pulled. It kind of makes sense. But if you report 99.2 one day and then 9.7 the other, or someone else reports 9.7, it looks stupid, right? It's just like it looks like this thing doesn't work at all. But it's pretty easy to fix this. This is 15 runs with no definitions, so you get 8 distinct answers. Um, but you can obviously fix this with context. Um, so the other 15 runs we did out of these 30 were the same thing, like all different engines. But all we did was we had a written definition of retention sitting where the agent could read it in a semantic layer. And when we did that, 15 out of 15, every single model, every single run came back with the same number. So all the engines, including the open one, which is much more affordable. Like it's like a seventh of the price of Opus, and I don't even know how much of a less price of Fable, probably like a 20th. Um, all were able to get that same answer. So um, this is like a small experiment, but it kind of gets to see how just adding simple context can do like huge improvements on the reliability of your models. So yeah, I think before we go further, like the other thing to note here is like models like did get better as well. So DBT has like an open benchmark. Their code's public. I'll share some of these sources because we're going to go through some different sources of how like DBT, Databricks, and Snowflake all approach context and semantic layers and stuff throughout this. I'll share those in an email maybe this evening. But like the models getting better does definitely help the reliability as well. You can kind of see here, right? Like Fable performs better with reliability than the open model, even without a definition. There's some more consistency there. Um, so models does help, but like at some point you basically get some diminishing returns there, or you can get the same amount of like increases in reliability from I would say like faster, smaller models than like these bigger, robust models just by increasing just by having more structured context layers within your system itself, which is a lot cheaper than like the tokens you would spend on a newer, more large, robust, expensive, slower model that's still going to get the answer uh, wrong some of the time. So here's kind of like the mechanism when you ask for a metric, like what happens with the reason you get all these different answers. Sorry, this says finds several readings here. It's a little off that there, but when you ask for a metric nobody's written down, the agent's still going to hand you a number. It's going to try and settle that definition itself. It's not like rolling the dice necessarily. It's going to read through your schemas. You can watch everything it's going to do in the background. Like that's why the smarter models are more reliable because they do more of the work to try and find like whatever their most logical definition for this is, and they will land on that same like most logical definition as they prescribe it uh, more consistently than say like some of the older models. So it'll read through your schema, it'll find several reasonable readings, it'll pick one that fits, and it's going to answer that one. It doesn't flag that it made that choice, right? Because from where it's sitting, the choice was reasonable. That's the whole point of these agentic systems to reason through these things for us. Um, but it's going to start that process over from scratch every time you ask it. And so in some cases, it will reason down a different fork. Um, I think I like this way that I think DBT said it in this paper that like previously, you'd get an error message and that's going to stop your work. That's going to stop a meeting from happening or something from being shared out. But now you have these like plausibly wrong numbers that are going into decks, that are going to reports, that are going to meetings that people are acting on. So a lot of what we really just want to do here in addition to adding context so we have more reliable numbers, is that when we know a number is not going to be reliable, we just want failures to basically show up as failures. So a human can intervene early on, whether it's like in the moment at runtime, adding that context, or adding that into the system at that time. So it doesn't make its way all the way to, a share out. What we'll talk about today is basically the kind of five things that we've found have fixed it for us. This is all, a lot of this is based on our own kind of experimentation uh, within our products, within our companies. And a lot of that is taken from kind of like I mentioned, like many of the like enterprise solutions, their approaches as well. A lot of them are kind of like circling around the same solutions at the moment. So I'll go through each one of these at a time. We'll start with defining a metric, which is what I've kind of been circling around this entire first session. It's the very lowest list thing you can do, and it has a pretty big increase in your reliability. So to do this, I mean, this is something we should always be doing prior to AI as well, but I would say probably very rarely happens in a very like robust manner. I've been in many meetings where uh, we're talking about a number and people think it's wrong, and it's just because they had an underlying assumption that the definition is different than what someone else defined it as. So the first thing we want to do is have some sort of layer, context layer, where we're writing down what a metric means. So you're writing the meaning, and at this point, you're leaving the SQL out of it. This is stuff like what are we counting, one row per what, so like the granularity, all those kind of like more like metric definition things without getting into like the tables or the SQL or anything, right? This is actually like it's going to help your AI, whatever sort of like you're leveraging for doing analytics at your company with AI. It's going to help it be more reliable. It's also just like really good thing for your company as well, regardless of AI, that everyone is aligned on a metric and you have super clear definitions around it. So either way, this is just good practice for kind of product analytics or any sort of analytics. The reason we leave the SQL out at this point is because your warehouse changes over time, right? Tables get renamed, columns get split. SQL written today can rot, but the meanings and definitions probably won't. You might change them a bit over time, right? As you're kind of hashing them out. But especially if you're reporting a metric to like the street, if you're a public company, like that thing's kind of rubber stamped and it's going to be that same metric forever, even if the tables that calculate it beneath it change over time. So that's why we separate the metric definitions from, say, like semantic layers that focus more on the tables and the SQL itself. The same definition has to still work if you move warehouses, for instance, or swap the model underneath. Everybody has some version of this, probably. Like Snowflake has metrics with a SQL expression and synonyms attached. dbt compiles them so the agent never writes the SQL at all, actually. It's kind of like a lookup. Databricks ranks SQL expressions as the highest value thing you can put in front of it. Then we put the definition in front of that same three engines and we'll kind of like run the grid again. Yeah, so in terms of your question here, do you define metrics in a separate document and feed it to the agent? So you can do this like many different ways. We have like a metrics.yaml file in our repo. You can have it like within the repo itself that your agent's agentic system is built in, or we also have it in a kind of like communal context repo that multiple people can add to that is separate from the agentic system itself, but that will point at it every time it runs a analytical question. It'll read in those metric definitions first and kind of save them in cache. There's different approaches for all these enterprise solutions as well. So I wouldn't say there's like one hard rule way of doing it. But I have basically, yeah, a kind of like YAML file that has all these things we talked about in terms of like the meaning grain, numerator, denominator, window filters. Um, So, like I said, once we have that definition read, then I mentioned this earlier, when we run it across all those engines again, all those 15 runs again, we're able to get land on the same number, 25.6. So that closes that drift that we saw at the start. That being said, it doesn't do anything about like the join or the data. This doesn't necessarily mean that 25.6 number is correct. So the second thing we do here that we've found is helpful is, you know, you can have a completely correct definition and still get a wrong number because the definition says what to count and not which, and not like the path to count it along. So I think the biggest error we see here is often when it gets the wrong cardinality. So cardinality just means like how many rows sit on each side of a join. So one customer has many orders and one order has like many line items. If the agent kind of like walks that relationship the wrong way around, a single order can show up 5 times and you can like have a bunch of duplicate rows that'll inflate the number without any warning. So even in our synthetic data set that we teach with, for instance, the same measure, one of the definitions without adding like information around joins and cardinality in a semantic layer, um, will come back as 5.9 million versus 3.1 million if it's just going off the definition itself. So the definition's like fine on both times, but one path duplicates a bunch of rows because we haven't told it anything about the cardinality it should work against. So you want to declare both how the table joins, how the tables join, how many rows are on each side. DBT does this with typed relationships, and its compiler will actually refuse a join that would duplicate rather than building it. And then Databricks and Snowflakes both make you declare um, cardinality up front if you use any of those. But having semantic layers that define joins and cardinality, in addition to after the definition, is to make sure that you're actually getting reliable answers time after time. I'd say there's kind of like a version of this that goes all the way called a compiled semantic layer, where you define the metric once, and then the system generates the SQL for you. So then in this case, the agent never writes inside that menu of like very specific definitions, but you start incurring a cost when you are trying to query things outside of that menu. So if you ask a question that the layer doesn't cover, um, those questions are obviously all going to score 0 because they're just going to get refused. While something more like a plain text to SQL that describes the definition and describes the joins and the cardinality, you're giving the agent the freedom to like reason through that and try to answer questions that you don't necessarily have like a one-to-one mapped answer to. Um, so in that way, you're kind of like increasing determinism, but you're not giving up the range of questions that you can answer. You can think of like the compiled thing as more like a just like a if then mapping where the way that we've discussed in the past 2 slides is more of like the actual agent reasoning through and trying to figure out what to write while being as deterministic as possible, which is what AI is meant to do. The third solution here that we found that gives you more reliable answers is providing worked examples. So like a real question paired with the query somebody already ran, checked, verified, and knows is right. So LinkedIn actually, and there's well, this isn't a link. This is just, but if you want to type that into your browser, you can. I'll share this out this evening. But LinkedIn published something pretty useful here they have a text to SQL system in production with hundreds of users every week. And what they did is they did what's called an ablation test, which means they effectively had a like evaluation score on their queries they're running, and then they one by one pulled out each layer of their context one at a time and measured what happened to accuracy. This is something a approach that we teach in our course as well, and something I would recommend every person does at their own for their own use case, because what works for one company data may not work for yours. The different ways of structuring context and the context layers there may differ from use case to use case. But they pull out each thing at a time and basically see what happens to accuracy. And so they pulled out like the table structures, they pulled out the groupings of which tables go together, they pulled the descriptions of tables and column names, they pulled out like the worked examples, which I'm talking about here, so like verified queries. They pulled out like a crowdsourced layer of domain knowledge and jargon. So think about like, I don't know, your Notion or Google Drive or Confluence thing where you're just kind of like dumping a bunch of like open-ended context about your company. And they see what the impact of removing each one of those things has on the overall accuracy of their text to SQL answers. And if everything they had worked examples moved the accuracy the most, which I think shows like how impactful these can be. Though these are, I'd say, like one of the bigger lifts in terms of building context. So, for instance, definitions, yes, these are somewhat of a big lift because you have to actually have meetings where people align on the definitions. But ideally, somewhere in your company already, there probably is stuff already defined, say in the dashboards you have today. Um, and then, the whole like cardinality and join stuff, you can honestly have agents build this for you just by going through your data models themselves. When you get into like building out a worked examples and verified queries, not only do you have to uh, find all of those worked examples, you have to verify that they're actually correct. So I know there's a lot of folks that I've worked in the past, including myself, who've written SQL that's like in the query history of our databases that's just like has errors in it. And so if you are having verified queries or worked examples that are incorrect, that's obviously going to make the output of your system incorrect too. So this is probably the heaviest lift one, but it is, I would say, worth doing in terms of increasing accuracy. So I mentioned like, yeah, so every company, every kind of enterprise solution also has some version of this. You can also make any of the stuff you can make on your own too. You don't have to use Snowflake or dbt or whatever Databricks version of this. A lot of the stuff we teach in our course, because we want to teach people like how it's actually built step by step, is just building it yourself in your own kind of centralized GitHub repo where all this stuff is stored in typically YAML or JSON files. But everyone has some version of this under a different name. So Snowflake calls them verified queries, and they store who signed off and when. Databricks calls them example SQL queries, and they have like some sort of cap on it, I think. I think Looker used to call them golden queries and now calls them verified queries as well. There's a couple of different having this kind of mapping of verified queries can be helpful for a couple of reasons, actually. So you can use it to steer at runtime. If I am going to ask a question right now, the agent can go look at the verified queries and it can, one, see if someone's asked my exact question before, and then it'll just run that query, or find similar questions and then look at the queries that ran those. And then based on what it knows about what I'm asking, what it knows about the tables that we uh, put into our like previous layers here, right? Um, it can reason through what changes needs to be made to that verified query to answer my slightly different question. Or you can hold back some of those queries. Don't ever use them at runtime, but use them as like your kind of like answer key grader set. So scoring the agent against it. This is really helpful when you're iterating on improvements to your agentic analytics system, whatever it may be, having some set of verified queries where you can see if adding or removing different things makes it better or worse. So this is kind of like the example I said, like with the LinkedIn did with ablation testing. They probably had a big list of kind of verified queries they're testing against. You just want to make sure you don't use the same pair for both. Um, if you use it for both, it's kind of like if you're familiar with machine learning, it's like using your training data as your testing data. So you'll kind of inflate your accuracy because you're cheating a bit. We get into all this in our course when we talk. We spend like a week and have a bunch of async content on evaluation and validation. So everything so far has been about giving the agent more information. But no matter how much you write down, there will always be some ambiguity left over. So that the gap that matter, you want one of two things: either a guardrail that makes it stop and ask you, hey, like I don't have enough information here. This is a very ambiguous question. I need to get more information from you, or you need a sort of like sensible catch-all default for the things that go missing most often. So for instance, like Looker, um, they take like the default route. If the user doesn't give, for instance, a date range, they'll have like a rule that automatically filters to say the last 12 months, same way every time. So at least you know if you're missing that context, because there is some like ambiguity there, uh, you know what it will default to. Um, and then the other angle you can take, like say like what we do like with when we run via Snowflake is the question is missing something it needs. We build skills so it like marks it as unclear and will actually stop the analysis and ask us for both context. Both are kind of fine. Um, Kind of depends. You probably want a combination of both of those. You probably want a default fallback. Um, and you also probably want some way of when it's like really unclear where it will stop and not just like make that guess without you. Um, the cool thing is that agents really know when things are vague and ambiguous. So if you ask a question to an agent like what is retention, and then you ask it directly whether that question or that definition is ambiguous, it's actually going to spot that a good share of the time. So if you put that into like a regular kind of question and answer setting, uh, the you can easily build systems where you have a guardrail where like if we flag this as ambiguous, don't proceed, add a gate here, and make us ask more context. So it's like it does a good job at knowing when to put the human in the loop if you tell it to put the human in the loop. But if you don't tell it to put the human in the loop, we've found that it will just find the most reasonable, uh, whether it's a join or a definition, or what have you, and run with it. It's also really easy to overdo this as well. Like, like you don't want to like if you have it gate too many times, you're obviously starting to lose some of the whole reason we're using like an agentic analytic systems, like you end up basically just doing most of the work yourself as well. And then also, if you have it ask bad clarifying questions, this can actually do a lot of damage as well. So you want to like not write that rule for gating so broadly. You just want that it'll like add friction every time somebody runs it. You want some sort of like narrow trigger. I think like the best trigger that we use is that if we is in a definition layer, if the metrics are actually going to fork based on a decision it makes, then we ask it to gate and stop. Okay, so last one, we talked about definitions. We talked about adding information around like your tables and joins. We talked about kind of like showed work, verified queries. We talked about incorporating gates based on ambiguous answers or vague questions, so a agent can get the human in the loop. And the last kind of thing we found here is having some sort of like unstructured context. This is kind of where people honestly often start, but it has like the least positive uh, impact I've found compared to all these more structured approaches. So almost every team probably has some sort of document or document repository, a folder of things that explains the business. Maybe it's in your Google Drive, maybe it's like Notion or Confluence or Coda or something else. All that unstructured stuff, domain knowledge, kind of like jargon, how we think about things, meetings that went on, transcripts and stuff like that. Um, so that ablation test I was talking about that LinkedIn ran where they pulled out each context layer, um, that score you're looking at is the share of answers a human expert like rated 4 out of 5 here across 130 questions. So when they gave them just like tables and columns, the raw structure, it increased that score by 9%. Um, when it told them like table grouping, so which tables tend to go together, it bumped it up to 11. When they started adding descriptions, kind of what we were talking about, like connect, um, that was its first like real jump up to 24. When we started adding worked examples, like I was talking about before, the thing we just talked about goes up to 49%. So that's a big jump right there when I had like verified SQL. Um, but when they added that kind of like crowdsourced domain knowledge and jargon, it actually went down to 42%. So their best score isn't one with like everything in it, all of this context in there. It's actually that rung before this like more unstructured layer gets put in there, which I think makes a lot of sense. When you add when you add these unstructured layers of context, and this may be totally different in the future as models get more and more robust and can reason through this stuff, I'm certain. Um, but you're adding a lot of noise, right? Like it, if documents that have like kind of irrelevant information or nothing specific to the question being asked, that's probably not going to do that much damage. But if it's starting to read in documents that are specific to or tangential to the question you're asking, and they have opposing views on what a metric is or how things are joined or what's important, you're just starting to add a bunch of like conflicting information that is trying to pull from and reason through like half, think about like all like the half correct kind of explanations that could be in there. Like if you're doing something like, oh, read everything in Slack and try and answer this question. So you don't necessarily want to balloon out the context around a question. I find that instead of being, it's better to just like be direct about how to answer it through those more structured formats of concepts of context. You can still use those kind of like you can still use AI to go through those more unstructured pieces of context, but I think you use those as a way to create the structured stuff. So a good example of this would be if you're coming up with a definition of a metric, you can pull in all the sources from all these different documents, all these different meetings, all these different Slacks, and come up with a few different definitions that you think may be correct based on those readings, and then go with your team align on which one of those is actually the correct one, and then take that just that correct one and put that in like your metric definitions semantic kind of layer. And then when you run the questions, that's what your agent looks at runtime. It doesn't look at all that unstructured stuff, but you can use that unstructured stuff as the kind of like base to build those structured things later on. That way you're not conflating all context. It's also cheaper, right? Like you don't want it reading all this stuff every time because that's also just going to cost you a bunch of tokens. This is like a very like teaser version of like week 4 of our 5-week course. Actually, we can spend an entire week on context management and engineering. And it sits after a week that we spend on AI evals. And this is on purpose because once you can actually measure your system, and we have many different ways to measure and validate and evaluate a system, then you can start to prove that a context layer earned its place instead of just guessing and thinking it looks right. So think back to that example where LinkedIn pulled out every single context layer to see how it affected accuracy. You can do that at your own company once you have a strong system of evaluation around your AI analyst yourself. Um, I'd say, yeah, a couple more things, and then we can get into like some questions. Uh, I'd say over the last year and a half, like all the kind of serious vendors in the space, like they all began drafting context with agents. So, um, I talked about it just now around how you can use unstructured context to start making more structured definitions. You can use agents to draft all like the schema stuff is pretty clear. You can start with agents to start picking out some of those verified queries by going through your query history. Um, that all being said, all of them also put a human approval step in it. So um, agents and can get you like a really good head start on building these context layers, but humans still do really need to review and verify it because if you're pushing in the wrong context to the agent that's going to run your data analysis, obviously, you're just going to end up with the wrong number. So the work shifts a little, right? It's less about writing this stuff from scratch, and it's more about kind of reading it, aligning with your team, and then having someone's name and specific data on there that's been validated, so people know they can trust it. I think there's a whole interesting kind of conversation that could be had around like who even owns that, right? Like, um, I don't really have a clean answer to this yet, but today, like, definitions, um, a lot of them, like in terms of like the SQL that runs, like that mostly sits with the data team, even though the definition itself probably originally comes from a stakeholder. Um, right? Like even though the definition sits with the data team, they're probably not the person in the room when somebody decides what gross revenue means for like the board deck. So I could see like PMs and operators and people
I
in
think that might have been
finance,
part of the issue. We just
being the people who actually like create those like definition layers themselves. That's like their like human judgment part, and then like maybe the data team is more the people who are verifying or creating those like worked example parts. I imagine within a year or two, there's probably going to be some sort of named function or teams arising around like people and teams who are just focused on context management and context engineering itself, probably sitting between, the data team and the stakeholders, or one of those people taking on that role itself. But kind of just like an interesting like new role I feel that could um, come up as it becomes more and more important to make these things actually work. Yeah, a little fun test, I would say. Try running a test I ran at the beginning on your own data, right? Like what I would do this week, take a metric that matters to you, ask, however, we had a lot of people in the chat say they are using AI for some data analysis. Try to ask it that same question in different sessions, like 5 to 10 times, and see if any of those answers disagrees. That's like the first way to start identifying gaps in your system and figuring out like, oh, okay, there's probably some opportunity here to um, improve like by adding different levels of context to make this more reliable. If you want to build this properly, we have a 5-week course called Agentic Analytics, Build an AI Analyst. It's going to start in the beginning of September. Week one, we build the thing, what agentic analytics actually is. We go through like GitHub, how to build your own AI analyst repo. We build your first skill. You design and build your own system rather than just copying ours. Week two, you expand it. We go into depth into the architecture of what agentic analytics systems look like. We integrate systems connected to real sources via MCPs like Snowflake, Notion, Google Docs. Week three is evals, as I mentioned a little bit before. We do this in 2 parts. We talk about trusting a single output. So when you're running an analysis at that given time, how do you trust it based on reliability, based on provenance, which is kind of like the audit trail of how it got to that answer, based on like predefined query checks and triangulation. So triangulation is having um, multiple takes at the same question and seeing if they end in the same recommendation. And then we also measure whether the system itself is improving. So this is what I was talking about, where you're building out like a ground truth data set, you're doing some sort of deterministic evaluation, you're building LLMs as judge for the subjective work, and you're seeing if uh, the expansions of your system or the additions of context layers is actually making it better or worse. Week four, we get into context. So we do like a super deep dive into what we did today, right? We're spending like an hour on this. We end up spending like 6 hours on it that week. So we get into context stores, where context lives, why placement matters, how to fix mislabeled definitions, the improvement loops paired with evals, writing contracts and checking them against gold cases. And then week five, we get into a bunch of different models. So, we talked a lot of our stuff. We talk about using Claude in our kind of free workshops because people are familiar with that. But we talk about different models coming out of Anthropic and why you don't necessarily need like the newest, most expensive model from Anthropic to make stuff work. We work with Codex. We go into open models as well. We talk about local versus cloud models. We swap between things. We show whether you can trust an open model as an analyst, and we have some models check other models work. So this will be like multiple live lectures. This is not record. We record everything. You can watch recordings afterwards, but these are not purely async content because everything is moving so fast that we are constantly rebuilding this course. So it's on the bleeding edge of what's going on with agentic analytics. I don't know any other course that's doing this. And then we also have office hours every week. So if you are just watching the recordings after the live sessions are taken, come to office hours and ask questions as well. And then we have a second course called AI Analytics for Everyone. This is like a very different problem. So everything today assumed you already know what to ask and how to tell whether the answer is any good. That's the part AI is still like really bad at. It'll happily run the analysis, but it won't tell you whether like the question you're asking is the wrong one for the business, or that the finding doesn't support the decision you're about to make. So that's what our other course, AI Analytics for Everyone, is about. It's about filling that gap between what AI can execute and what humans still need to do. So if you're someone who wants to use AI in your decision-making process, but you don't necessarily know how to run the whole like end-to-end like analytical thinking process, like pick the question worth answering, pointing the tools to your data, breaking a metric into its drivers, finding the root cause, establishing cause and effect, running experiments, turning findings into decisions people can actually act on. That's what this course is about. It actually started 2 days ago, this current cohort, but that first session's recorded. A lot of this content is more async, so you can watch at your own pace. And then we have a couple office hours throughout the week. So we're actually leaving registration open until the end of this week, since it's so easy to catch up on the first week if you still want to join this one. And for both of these, we're offering 20% off. You can take your phone out and scan the QR code right now for either of these, and it'll bring you to the 20% off promo on those courses. Or you can go check us out on Maven, and you can use the codes below to get 20% off. We'll send this out in that email there as well. Okay. I wanted to have way more time to open for questions or anything, but I know we only have a few minutes left. I can stay over a bit. Um, and then, yeah, we will go through in terms of like if where is the code? We have an open source repo if you want to check that out. Maybe how you can drop that into the chat as well. A lot of our courses here, you'll build this all from scratch though. So that code is you don't have to know how to code, but you're going to build that within like kind of your context. All right. Any questions that came up in the chat, higher Shravia, throughout the session that I didn't answer?
Yeah, I think there's a few that would be interesting to answer. One is any recommendations besides your course, which looks very interesting, on where to learn more about how to build context.
There's nowhere on the whole planet except for our course that does this. I don't know. I would say probably YouTube. I actually haven't seen any courses that are just about like building context, but I guarantee you there's a bunch of stuff that's free on YouTube if you look up like um context management. I will share. So actually what I'm gonna do, well, I'll say in 2 weeks we're gonna do another free session on some context stuff. So join that. Maybe how you could drop the link to that session in 2 weeks. It's like it's going to be about like building more into like the definitions layer. So that first thing we talked about. And then I will send an email this evening, and it's going to have a bunch of sources to some of the articles and research published by some of those enterprise companies who have been trying to solve the context um, problem. So I'd read through those for sure. That would be a really good starting point. So I'll share that. I haven't seen a course per se on context. There's a whole course on evaluation on Maven. Uh, if you're interested in that, I don't think it really goes into that one doesn't necessarily go into like how do you uh, increase the quality of the output via context. It's more around how do you measure the quality, which we'd spend a week on as well. What other questions?
Ranjan asked, how successful has been text to SQL? What are the biggest challenges where or what type of use cases slash SQL it has been successful? Are these being used in production?
Yeah, I mean, text-to-SQL has been around for a long time, right? It's gotten a lot better when LLMs came around. Um, I barely write SQL anymore. Probably stopped writing SQL. I'm pretty good at SQL and pretty fast, but I still find like AI is just faster than me. I think that if you're really good at SQL and you can read it, uh, it's pretty awesome. Like you can go pretty fast, especially if you have it looking at your query history of things you've ran before. We find that like, if you think about it, the majority of the things that you're querying are probably within the same realm day to day. I think where it probably doesn't perform as well is people who do not know how to read or write SQL, who are asking novel questions that haven't been asked before at a company, and thus there's not existing work example for. It's going to, in that case, kind of like, um, you know, reason through what it thinks could be a reasonable answer. But if it doesn't know how to anything to go off of, and if the person kind of leveraging it to answer a question can't review it themselves, I'd say that's a pretty risky use case. But in cases where you can review it yourself, or in cases where like similar questions have been asked in the past, I think it does really well.
All right, maybe a final one. Where do you see QA teams participating in this? How are the roles evolving?
Hmm. I don't know. It's kind of interesting. A lot of companies don't have QA teams, right? Like, I think a lot of companies used to have QA teams, and then it's kind of like at some point, like QA became part of like the regular dev's job. So I would probably say like um with everything, there's probably a bit of like, that happened before AI. I would say there's probably a consolidation of like roles within a single person's job, no matter what. I would say anyone, I guess how I would think about it is like for me in my work, what I can just say is that I've gone from doing analysis to building agentic systems that do analysis for me to and manually reviewing those to now building systems of evaluation that review the agentic systems that do the analysis for me. And I think that probably becomes part of everyone's job at some point. If anyone is trying to leverage AI to automate their workflows, they also have to know how to evaluate it and validate that it's right and know when it's also wrong. So I'd say like QA is going to be really strong already in that mindset of like knowing how to evaluate something is right or wrong or somewhere in between. But uh, I don't know, they might be taking on more of the other dev work as well, because I don't really think there's a centralized team that's just like, I'm going to build your evaluation system for your bespoke automated workflow of what you do day to day. It's too slow. But yeah, I don't have a super good answer for that. I think just in general, like everyone should be probably doing a lot more QA now. If you're using something non-deterministic to run your work for you, you have to QA it. But I think people who have been doing that for, their career can be set up pretty well to do that.
Um, oh, Raj just added a question. How do you generalize the learnings here for other types of
Yeah,
app?
yeah. For stuff outside of analytics, I think so obviously uh like verified queries doesn't generalize, right? That's very much of a analytics relevant thing to do. But you could have other types of worked examples of like examples of a workflow someone goes through. For instance, example might be when we're building agentic systems for lawyers, like having the multiple iterations of a document or a contract that they're editing to show from start to finish how they got to the end product might be a good worked example. I'd say anything evaluation, yeah, eval stuff is going to be generalizable. Um, but yeah, I think context, the type of context and how you structure it and store it is going to be a little more application dependent. Because even like, right, metric definitions, that's pretty clearly an analytics thing as well. Um, I would say the most generalizable stuff that we teach in our course. So if we go back to build an AI analyst you can trust, I would say like week four is probably the least generalizable. As like week one, two, three, we're building a agentic analyst. We're expanding it. We're putting evals around it. Everything that we teach here could be a totally different use case with nothing to do with analytics at all, and it would generalize well. Same thing with week five as we swap and test different models. But how we're teaching context, we're going to teach it very specifically into how do you structure context so it does well for agentic analytics use case. Just because like I think that's kind of like the name of the game I'm seeing right now is like having specific structures for your use case is where I'm seeing a lot more gain in the accuracies compared to just like throwing big blobs of context at it. Okay. I think that's all the time we got. But if you have more questions, feel free to ping me on LinkedIn. And you know what? I'll share our Slack group real quick. If you're not in our Slack, we have a Slack community where you can ask questions as well. All right, cool. Thanks, everyone. Hopefully, see you next week or at another one or in our course. Have a good day.